Hi, well, we've been quite busy here in the office, so quite a long time we don't publish any video, but we will show you why. Sorry for the mess, we are still upgrading the printer, redesigning some key elements of it, and well, I am also redesigning the Terran Marine armor because, well, those pieces are quite nice to see, but too small on its size. Well, they fit quite good on the foot and also on the shin, but going up all the proportions went so wrong that, well, better to redesign everything from the ground up. Last time we talked about the screws, the Z-axis and the reductions. Now let's come to the hard part, the belts. With such a big gantry, as I maybe told you in one of the previous videos, the big problems are the belts, not the belts themselves, but the tensioning of the belts. They're quite long, and when you have to manually pull them and glue them or screw them if you want, they're quite hard to tension. And for example, if we see this one, we see it quite dancing. It's not good at all, because if the belts are not tensioned properly, you could have some steps skipping. I mean, not on the motor, but on the final print. Now, you can avoid that by using simple tricks. We will talk about it on a later video. To properly talk about it. Okay. Now, one thing I have encountered, and you may be very well interested on it, is an issue I had with those pesky drivers. Now, one thing I have learned is that yes, you can connect many motors in parallel on a single driver. Now, we are not using any encoders, we are not using any kind of feedback from the motors, so if we put two motors on the same driver, is not sure that we will get the same amount of steps that we ask from a motor to both motors, maybe in the case of two motors on one driver, so like we have down there. I have already ordered some external motors that we will add, and we'll make a video also about that, because it could be quite interesting to see how they are wired, how they work, etc. Anyway, after, let's say, some kilograms of spools, so you can see only some of them I have already trashed, and well, they lasted quite long, let's say 25 kilograms before failing. Now, I've already switched them, but the substitutes for those, they are already condemned to die too, as they did, because maximum amps is something to really care about. You cannot simply, like I did, put some motors, drive them with less amps that they need, and simply hope that it will work, because after some time those little drivers will fail, and they did. You see, this little integrated circuit is a DRB 8825 from Texas Instruments on a simple pololu arrangement, let's say. Quite common on big motors for 3D printers. But when you do like I did, using big motors and two of them on one single driver, you are quite asking too much to them. Now, those motors, they use 1.5 amps each. So, for two of them would be 3 amps. And this driver allows for a maximum of 2.2 amps. So I'm asking for like 50% more for its maximum amps. And while we are actively cooling them by using two fans, one for the intake and one for the outtake, creating an airflow which flows ideally around the drivers, they're not cooled enough. And even if they are cooled enough, I mean maybe putting them in mineral oil like some extreme water cooling techniques do for the computers, we're still asking too much, and they will ultimately fail like those one did. Now, something you will hear if you do the same is some noise. Lately, I mean on the last time those drivers worked, when they were moving the motors, I've heard a lot of noise from the motors, like some steps were bulked. I mean, instead of making, for example, let's say 3 steps, like one step, one step, one step, one step, they were all grouped in groups. So for example, let's say 3 steps, nothing, nothing, 3 steps, nothing, nothing. So making big moves concatenated, and it was so noisy, you have no idea. And what happened is that all the layers were pesky. Let's say an example of it. Maybe could be more useful to see it than to just speak about it. Okay, when the driver failed, I've swapped them. I mean, one of these was totally cooked and didn't work anymore. So that's why I've discovered the problem I was having was not a mechanical issue, but just an electronic issue. I swapped them with the extruders. I have 2 of them. Actually, only one is working because I had a big failure with this one. If you can see, I had to really carve out the nozzle and the heat exchanger because something bad happened inside, and there is a lot of friction for the filament coming through, and is not working anymore, so I have to swap it. Anyway, the one driver, this one I am holding in my hand, which was still working but still grouping steps, well, I placed it driving that stepper motor, the one for the extruder, and this is what I got. As you can see, the extrusion was not linear anymore. I had small blobs, as you can see maybe here from the perimeter, of big extrusion and some traction, you see, while moving in the direction of the extrusion. You can see maybe from the profile of the lowest one, you see like small drops, the shape of a drop. You see the fat part here, then going thinner, then a big drop, thinner, another drop, thinner, and so on. That's because it got cooked, like the other one, which literally is not working anymore. I even took out the heat sink because, well, it's cooked. Ready really for the trash bin or just to make a video about it. The replacement, as I told you, they are already condemned because I am pushing them to the same limit that caused those to fail. Now, as you can see, they are quite different. They have the thermal exchange pad on the bottom. Those drivers put the chip underneath because this kind of stepper driver chipset, this one from Texas Instruments, they are designed to exchange heat from their bottom, not from their top. So it's pointlessly useless to attach the heat sink on the plastic part of the chipset, the outside. You should drain the heat from the PCB. So the more your Pololu compatible driver has in copper in the inside, the better. And I mean, for the heat exchange, which is key on those drivers. Yes, they have thermal protection, yes, they have voltage protection and everything, but better be safe than sorry, like I was. In the next videos we will show you how to properly design the belts. This was just a brief introduction on many of the issues we will talk about in the next videos. So we will address first belts, then we will talk about the motors, how to properly wire them, and why you should do one motor, one driver, avoiding frying them like I did. For now, see you next time. If you have questions, whatever, suggestions, please write them below. Please subscribe, like the video if you liked it or not, or whatever, the same stuff always. Bye bye, see you next time.